Hello, everyone. My name is Zachary Farah,
My name's Zachary Edby.
And my name is Ahmed. Go, sir.
and I'll be introducing the DCN 320 term project. So this project focuses on designing and implementing a virtual enterprise network using Ubuntu server on VirtualBox. So let me first talk about the topology. So our virtual network consists of three core routers, router 1, router 2, and router 3, and each responsible for connecting different sections of the network. So router 1 connects to eternal users and services. Router 2 acts as an eternal gateway, simulating an ISP connection, which is our ISP gateway that we have right there. Then we have router 3, which connects to our internal department. So let's talk about our devices and IP planning. So PC 11 and PC 21 are server machines connected to router 1, and they PC 11 is a part of the 192.168.10.0/24 subnet, and PC 21 is a developer machine that also connects to router 1, which is a part of the 192.168.20.0/24 subnet with a default gateway of 192.168.20.254. Then we have PCIT, which is a machine from the IT department, which connects to router 3 and is a part of the 192.168.30/24 subnet. And then lastly, we have PCISP, which represents an external system in the 172.130.0.0/16 ISP network and connects to router 2. So you can see our ISP address. The IP of it is 172.130.0.1, and then what it routes to are the different machines that we have, which is PC 11, PC 21, and our IT machine. Then lastly, we're going to talk about our DHCP bonus. This file is going to give R2 DHCP. So as you can see below, the subnet for that is 172.30.0.0. And it's the only IP address that is assigned to that, which is 172.30.255.254. And that's
And
about it.
then, so for the trace routes, this is the trace route from PCISP to PC11. And as we can see, it goes from R2 to R1 to PC11. And for the trace route between PCISP and PC21, which is on the developers network, as we can see, it also goes from R2 to R1 to the developers network. And for trace route to PCIT from PCISP, as we can see, it goes from R2 to R3, which is that IP address number 2, to the IP address of PCIT. Now, as for the routers, I will start with router 2. Here's the netplan file for it. And as we can see, it has 4 physical adapters, all connected to the internal network. One adapter for the R1, R2 network, one adapter for the R2, or sorry, 3 adapters. One adapter for the R2 ISP network, and one adapter for the R2, R3 network. And in the netplan file, we can see that it has a static IP address for the R1, R2 network that is 10.10.10.2, and the static routes are commented out. The second adapter receives DHCP from R2 ISP, and the third adapter has a static IP address .10.10.10.9, and static routes are commented out in favor of OSPF routes, as we can see in the IP route table. Now, as for R1, we have 4 physical adapters, I believe, all connected internally. As we can see, one connected to the servers network, one connected to the developers network, one connected to the R1, R2 network, and one connected to the R1, R3 network. If we check out the netplan file, we can see it has 4 static IP addresses. One which is the last usable IP address in the subnet, 192.168.10.254. Once again, the last usable IP address in the developers network, 192.168.20.254. A static IP address in the /30 network, which is R1, R2. Here's the static IP address for adapter 3. And for adapter 4, here is the static IP address. And as we can see, they are all applied to the correct adapters. And if we check out the routes, once again, static routes are commented out in favor of OSPF routes. Now, finally, for R3, we have 3 adapters, one connected to the R3 IT network, one connected to the R1 R3 network, and one connected to the R2 R3 network. So we have the last usable IP address for the R3 IT network, 192.168.30.254. For the second adapter, we have a static IP address .10.10.10.6 in the /30 subnet for the R1 R3 network, and a static IP address 10.10.10 1.10.10/30 for the R2, R3 network. And once again, if we check out the routes, we have our static routes commented out in favor of OSPF routes. And the default, as we can see, the default gateway for R3 is R2, as well as it was for R1. Now I'll give it to Ahmed to finish the rest.
All right, wrap things up by talking about the client machine and connectivity testing. First off, the PC11, this machine is on the server network and it's connected to R1 as its default gateway. It has a single network adapter and uses a static IP 192.168.10 and 1. Next, we're going to talk about the BC21, which is on the developer's network, also using R1 as its gateway. Same setup, one adapter static 192, 168, 20, and 1. The third one is the BCIT. It's connected to the IT network and uses the R3 as its default gateway. It's configured similarly with the static IP 192, 168, 30, and 1. For the testing, we run trace route between BCIT to BC11 machines and verify that traffic could travel across routers. For example, trace routing from BCIT to BC11 went through R3, R1, and to BC11 as expected. We also tested network access from BCIT by routing through R3, R2, BCISP to the internet. And that's our presentation. We built fully functional virtual network with DHCP, dynamic routing using OSPF and internet connectivity. Let us know if you have any question, and thank you for listening.